Alright, so this is on your factoring strategy sheet. We're going to add the last one. It's under the Magic X branch here. This is called perfect square trinomials. It's different than the difference of squares. They both involve perfect squares, but difference of squares only had two terms. It always had subtraction. These ones usually have three terms. Technically, it's under the Magic X category because you can use Magic X for them also. But for the most part, it's there's another rule that's a little bit easier if you want to use it. If you just want to use Magic X, go for it. This rule looks like this. You might have two situations. You've seen this before. A squared plus 2ab plus b squared equals, in parentheses, a plus b squared. Or it might be a squared minus 2ab plus b squared equals, anyone remember? A minus b to the power 2 squared. Okay, this is a little shortcut. It only works for perfect squares, and I'll explain how you know in just a second. This whole page is now complete. You have all the factoring strategies that you need. On your test, it's not going to say factor by grouping. It's going to give you 9 problems and say factor, and you're going to need to figure out which strategy that you want to use. All right. So here's the actual notes. We just learned about perfect square trinomials. Okay, they are of the form, meaning they look like this. There's two options. I just wrote it for you. It's either a squared plus 2ab plus b squared, or it's a squared minus 2ab plus b squared. These factor to become either a plus b squared or exactly a minus b squared. For these two examples, you don't need to write all the words. I'd maybe just look at this. It's asking you, is this a perfect square trinomial? I'm going to show you kind of a strategy of how you're going to want to set this up. If it's a perfect square trinomial, that means it matches one of these two forms. The easiest way to do this is to first test the first number. So I'm going to write over here off to the side. My first number should look like what? A squared. So I'm going to say a squared equals 16n squared. Is 16 a perfect square?
Yeah.
Yes. Is n squared a perfect square?
Yeah.
It is. It's an even power. 2 is an even power. So that means that a, not a squared, but a would be, what's the square root of 16? 4. And the square root of n squared is just 1n. Those are both perfect squares, so it worked. Now I'm going to check the 9. That's the next easiest. The last number should look like what? B squared. Actually, I should use this one because it's a minus. It's the same thing either way. But B squared equals 9. Is 9 a perfect square? Yes, so regular B, not B squared, would be 3. Now here's where you have to check it to make sure that it's actually right. The middle one is probably the most work to check, but it's not that hard. I am checking to see, does this match my middle term? So does negative 2ab equal negative 24n? You're like asking that question. I'm even going to put like a question mark by it. Well, negative 2, what's a? 4n, so I'm going to put in parentheses 4n. What's b? 3. I'm checking to see, does that equal negative 24n?
Yes.
Negative 2 times 4 times 3. Negative 2 times 4 is negative 8. Negative 8 times 3 is negative 24. I still have the n. Equals negative 24n. Do those equal each other? So is this a perfect square trinomial? Yes, because it matches this form. All 3 of the pieces matched. So it's asking, determine if it's a perfect square trinomial. We would say yes. And then it says factor it. Well, the good news is you can save yourself all the magic X hassle by just using this. If it's in this form, right here I'm using the second one because it's a minus, it's going to factor out to be a minus b squared. Well, what was my a? 4n. Minus, what was my b? 3 squared. And then you're done. Not too bad. Let's try this one. 16x squared. I'm going to do the same thing. I'm going to test it to see if it looks like a squared. So I'm going to say a squared equals 16x squared. Is 16 and x squared perfect squares?
Yes.
Yes. So a equals what?
4x.
Good. Next I'm going to check 15. So b squared equals 15. Is 15 a perfect square?
No.
Nope. So I would say no, because 15 is not a perfect square. Well, 32 doesn't have to be. 24 is not. It just has to match that middle form. Okay, 3 more examples. Write all 3 of these down. We're going to do all 3 of these. Okay, we'll start on the first one. I'm going to check the pieces again. So my first piece should be a squared equals x squared. What would a be? X. Good. I'm going to check my second piece. B squared equals 64. Is 64 a perfect square? Yeah, so B equals what? 8. Now I'm going to check this middle term. What should that be equal to?
Negative 2.
Yeah, negative 2ab equals negative 16x. I need to check it to see if that's true. So I'll put a question mark. What was A? So I'll plug in X. What's B? 8. B squared is 64, but B itself is 8. Does that equal negative 16x? It does. Negative 2 times 8 is negative 16. We have the x. Those match. Is it a perfect square trinomial?
Yes.
Yes. How would you factor it? We would have a minus b, so x minus 8 squared. And then you're done. Let's try the next one. M squared equals a squared. Is that a perfect square? Yeah. So a equals m. I'm going to check 25. B squared equals 25. Is that a perfect square? Yes. So B equals 5. We'll check the middle step term. This time it's positive 10m, so I'm going to have positive 2ab equals 10m. Question mark. We're checking it. What was A? M. And B is 5. Does that equal 10m?
Yeah.
2 times 5 is 10. 10m equals 10m. Check mark. So is it a perfect square trinomial? Yes.
Yes.
What would it factor to be?
M plus 5 squared.
Perfect. Last one. I'm going to say a squared equals p squared. So what's a? Good. B squared equals 64. Is that a perfect square?
Yeah.
Yes. So B equals 8. Let's check the middle one. 2ab equals 8p. What do we plug in for A? And what do you plug in for B? 8.
No.
2 times 8 is 16p. It's supposed to equal 8p. Does it work? No. So is it a perfect square trinomial?
No.
No. So I'm just going to say 16p is not equal to 8p. That's what it was supposed to be. Okay. Feel like you got the hang of that, sort of? Okay. I don't know why I didn't show this to you sooner, but I need to, like, officially, I think I did talk about it maybe first and second try. We need to talk about officially how you find the square root. The square root of a number has a positive and a negative solution. Do not write down every single one of these. I'll tell you which ones to write down. You can just watch this part for now. What it means is if you take the square root of this, that cancels out the squares, right? So you'd have x equals, it's not just 7 though. Your calculator, when you type that in, it only gives you 7. It actually is plus and minus 7.
Yeah.
Why is that?
Because negative 7 times negative 7.
Yeah, because 7 squared is 7 times 7, which is 49. And negative 7 squared is negative 7 times negative 7, which is also 49.
Yeah.
So you have to remember that it's the plus and minus. It's both. So on this one, what would it be?
Plus minus 8.
Y equals plus and minus 8.
Yeah.
To solve this one, this might be one worth writing down. 2a squared plus 2 equals 164. Yeah, you'd subtract 2. 2a squared equals
Divided by 2.
162. First subtract. Then you divide by 2. A squared equals 81.
Plus
Then what?
9.
Square root. So you'd have 8 equals plus and minus 9. On this one, can you take the square root of a negative number?
No.
No. So this is no solution. Technically, it's no real solution. You're going to learn later in Algebra 2, this is technically actually 2i. I is an imaginary number. I wish I could teach you guys that. It's like my favorite stuff to learn about, but I can't. It's not Algebra 2. It's all right. Okay, this is one worth writing down. What do you do? Add 36. So 2x minus 3 squared equals 36.
Square root.
Take the square root. 2x minus 3 equals not 6.
Plus minus 6.
Plus and minus 6.
Split them.
Then you split them, exactly. So what that means is that you'll have 2x minus 3 equals positive 6.
2x minus 3.
And 2x minus 3 equals negative 6. Do not forget to split it. Then you can add 3. 2x equals 9. Divide by 2. X equals 9 over 2. Over here, you can add 3. 2x equals negative 3. Divide by 2. X equals negative 3 halves. This one's also worth writing down. Right here.
556.
Yeah, you want to get rid of that fraction. Multiply both sides by 56. So I'd have x squared equals,
168.
thank you, 168. It's not a perfect square.
No, it's not.
Whoa.
But you can take the square root still. And x is going to be approximately plus and minus. Square root of 168 is approximately 12.96. Guys are doing great. A couple more examples.
And then we're done.
And then we're done. Okay, so now we have all of our factoring strategies available to us. Greatest common factor, grouping, perfect squares, difference of squares, magic X. Lots of options. This, when you're looking at this, I would be thinking to myself, 9 is a perfect square number. Is this one of those cases where we can do what I just taught you? You don't think so? How could you check?
Oh, I thought, never mind.
A squared equals x squared. So A would be x. B squared is 9, so B would be 3. This middle term, I need negative 2AB to equal negative 6x.
It does work.
Negative 2 times x times 3, does that equal negative 6? Yeah. So this is a perfect square trinomial. How can you factor those? X minus 3 squared equals 0. Well, x minus 3 squared really means you have x minus 3 times itself. You can split this up so that it's x minus 3 equals 0, but it ends up being the same thing, you know what I'm saying? You wrote the same thing twice. So what is x? Just 3. You'd have x equals 3 and x equals 3. We say that this is a multiplicity of 2. You'll learn about that in Algebra 2. But this time it only really has one solution, x equals 3. How'd you do this one? A couple ways you could go with it.
Square root.
Yeah, you could take the square root. A minus 5 equals,
8
not just 8,
plus negative 8.
plus and minus 8. So if you're going to do it that way, don't mess it up. A minus 5 equals 8. A minus 5 equals negative 8. Keep going. So A equals 13.
8 equals negative.
All right, you guys feel good with those? Okay. Here are your homework problems. I put a little note down here. Remember that the vertical motion equation is this. We had that in our notes. If they don't tell you what V naught is, you can assume it's 0. That's starting on the ground. Or, yeah. If they don't tell you the initial velocity, that it's not a factor in there. That's one of the homework problems.